Hey everyone, and welcome. Today we're going to break down a neat string manipulation problem from LeetCode, sort vowels in a string. It sounds simple on the surface, but it's a great exercise in organizing your approach. Let's dive in. Alright, let's look at the official problem description. I'll give you the simple version. We're given a string. Let's call it sys x. Our job is to create a new string, t, based on s. So what does this actually mean? Imagine the consonants are like unmovable pillars in the string. We can take out all the vowels, put them in a separate pile, sort that pile, and then carefully place them back into the empty spots left by the original vowels, one by one. And a key thing to remember is that case matters. The sorting is done by ASCII value. In the ASCII table, all uppercase letters come before all lowercase letters. So, a capital E will always come before a lowercase a in our sorted list. Okay. Let's walk through an example to make this crystal clear. Say our input string is LEETCODE, Stoller, Borpun. Stoller tone, Stoller joller in Zanton. Capikas. First we scan through it and pull out all the vowels. That gives us EEEODEEZ and EE. Make later, the consonants L, T, C, D stay right where they are, creating a kind of template with empty slots. Next we sort our pile of vowels. Remember, ASCII order, capital E comes first, then capital O, and then the two lowercase e's. Finally, we take this sorted list of vowels and fill in the empty slots in our template from left to right, and that gives us our final answer, LEOTCEDE. So our first approach is the most straightforward one, which I'll call the sorting method. It's a simple two-pass process. On the first pass, we just go through the string and collect every vowel we find into a separate list. Once we have that list, we use a standard sorting function to sort it. Then, we do a second pass to build our result. We look at the original string character by character. If it's a consonant, we add it to our answer. If it's a vowel, we ignore it, and instead add the next available vowel from our nice sorted list. Alright, here's the Python code for that sorting approach. It does exactly what we just discussed. Let's break it down a bit more. First, we initialize an empty list to hold our vowels. We also define a string containing all possible vowel characters for easy checking. Then we loop through the input string s. For each character, we check if it's in our vowel string. If it is, we add it to our list. After the loop finishes, we just call the built-in sort method on our list of vowels. Pretty simple so far. Now for the second part, rebuilding the string. We create an empty list for our result and a pointer, let's call it vowel index, to keep track of which sorted vowel we're on. We loop through the original string again. If the character is a vowel, we append the vowel from our sorted list at the current vowel index, and then we increment that index. If the character is a consonant, we just append it directly. Finally, we join the characters in our result list to form the final string. Okay, that first approach works perfectly fine. But can we do better? Think about it. We're using a general-purpose sort, but we only ever care about sorting 10 specific characters, the 5 vowels in upper and lower case. When the set of items to sort is small and known, we can use a more specialized and faster technique called counting sort. Instead of collecting vowels and then sorting them, we can just count how many of each we find. Here's the code for the counting sort approach. It looks a little different, but the core idea is simple. Let's walk through it. First, we initialize a dictionary or a hash map to store our counts. We loop through the input string just once. If we find a vowel, we increment its count in our map. For example, if we see E, we add 1 to the count for E. Now for the clever part. We don't need to sort anything. We can build our string of sorted vowels directly from the counts. We create a special string, AEIOU, which already has the vowels in perfect ASCII order. We loop through this string. For each vowel like A, we look up its count in our map and add that many A's to our sorted vowels string. Then we do the same for E, and so on. This automatically creates the correctly sorted sequence of all the vowels from the original string. And this last part is exactly the same as in our first approach. We loop through the original string one more time. If we hit a consonant, we add it. If we hit a vowel, we add the next character from our sorted vowels string that we just built. The logic is identical, we just got our sorted list in a more efficient way. So let's talk about performance. For the first approach using a general sort, the time complexity is dominated by finding the vowels, which is order n, and sorting them, which is order v log v, where v is the number of vowels. The space required is order v to hold the list of vowels. The counting sort approach, however, is faster. Its time complexity is just order n, because we only do a few simple passes over the string. And its space complexity is order 1, or constant, because the map we use to store counts will never have more than 10 entries, no matter how long the input string is. So counting sort is the clear winner here, in terms of efficiency. So to wrap things up, what are the big ideas here? First, always try to deconstruct a problem into smaller, manageable steps. Here it was identifying the parts to change, processing them, and then putting them back together. Second, this problem is a perfect example of choosing the right tool for the job. A general sort is fine, but recognizing that we have a small, fixed set of items allows us to use a much more efficient algorithm like counting sort. It's a great pattern to keep in mind for future problems. If you enjoyed this problem and want to keep practicing, the learning doesn't have to stop here. I've organized all my video solutions into handy playlists. Whether you're looking to grind through more LeetCode easy, medium, or hard problems, or you want to master a specific topic like sliding window or dynamic programming, I've got a playlist for you. It's the perfect way to focus your study sessions. Go to the Playlist tab and find a playlist that fits your goals. Hope this LeetCode solution breakdown made sense. If it helped, give that like button a click, maybe subscribe for more, or drop a comment if you have questions. Make sure to turn on the notification bell so you know straight away when I upload a video, because I upload videos daily. This channel doesn't make any money from sponsorships or ads yet, so if you're feeling generous, there's always the Boba Fund. Keep coding, and I'll catch you in the next one.